Hello everyone, my name is Devamitra and I am a second year student from the Department of Computer Science and Engineering at Shriram Engineering College. Today I am going to present Dijkstra algorithm and its Java implementation. In this presentation, I will explain the algorithm, its steps and the program implementation with output. Okay, let's see what is Dijkstra algorithm. Dijkstra algorithm is used to find the shortest path in a weighted graph. It calculates the minimum distance from the source node to all other nodes in the graph. In this algorithm, each connection between node has a weight which represents the distance. It is widely used in the GPS navigation systems and computer network routing. The steps of Dijkstra algorithm are as follows. First, we initialize the source distance as 0 and all other distance as infinity. Next, mark all vertices as unvisited, then select the vertex with the minimum distance. After that, update the distance of its adjacent vertices if a shorter path is found. Then mark vertex as visited. This process is repeated until all vertices are processed. Now let us look at the program implementation. First we import the java.util package which includes the classes like scanner, ArrayList and arrays. Next we define the main class Dijkstra Smart City which contains the entire program. Inside this we create an edge class which represent a connection between two locations. It stores two values, the destination node and travel time between locations. A constructor is used to initialize these values. Then we define a constant INF equal to 9999 which represent infinity when no path exists. Then the main method where program execution begins from here. We define a scanner object used to get input from the user. Then we display the title of the program and we get the input from the user as enter the number of vertices which represent location. Next it asks for the number of edges which represent roads. The graph is represented using an adjacency list where each vertex stores connected edges. Then the program asks the user to enter each edge in the format of source, destination and travel time. And we set loop to read all edges. Then we read the starting location like example. Then we read the starting location. Because this program reads the starting location and destination location as characters. So next we read the destination location and then it also reads the time travel between them. These character values are converted into index values using ASCII conversion. Then the edge is added to the graph. Since the graph is undirected, the reverse edge is also added. Finally, the source node is set as A and the destination node is set as F and the Dijkstra function is called. We assign source value as 0 and the destination value as 5. Inside the Dijkstra function, we create three arrays. The distant array stores the shortest distance from the source. The parent array stores the previous node to reconstruct the path. The visited array keeps track of visited nodes. All distances are initialized to infinity and the source distance is set to 0. Then for loop runs v minus 1 times to process vertices. Then we initialize u equal to -1 and min equal to inf as the data type of integer. This variable is to store vertex with the minimum distance. The algorithm then runs a loop to process all vertices. In each iteration, the algorithm selects the unvisited node with the minimum distance. The node is marked as visited, then all its neighboring nodes are checked. If a shorter path is found, the distance is updated. The parent of the node is also stored to reconstruct the path. Finally, the program prints the shortest travel time from A to F. It also prints the shortest path using a recursive function, which displays the path step by step. Now let us see the output slide. Now let us observe the output of the program. First, the title of the program is printed, and then the user enters the number of vertices and edges, and then the user also enter the time travel between locations. The program processes this input and applies the extra algorithm to find the shortest path from the source node. Then the output, the shortest time travel from A to F is printed as 8 minutes, and the shortest path is A to C, C to E, and E to F. Thank you. Thank you.